So question 9. Question 9 starts off, we have a kind of an area and volume context here. O'Connor's juices own a number of factories producing fruit juice. Once prepared orange juice is stored in large storage tanks prior to packaging. The tanks are cylindrical and have radius R meters and height H meters. The curved surface of the cylinder is made from a rectangular sheet of stainless steel measuring 132 centimeters squared. So, as always with the problem solving question, you'll be advising students to read through it a couple of times. With the key bit here for right now is obviously we're dealing with a cylinder, and the curved surface of this cylinder is 132 meters squared. It asks us about the volume of the cylinder and says that it's, show that it's equal to 4,356 all over pi times h, and that'll be meters cubed. So what do? Okay, we start off. We know that the curved surface area of a cylinder is 2 pi rh. In this case, we know that's equal to 132. I'm going to isolate r. The reason for that now will be obvious in a moment, but that's going to be 132 divided by 2 pi h. My volume of a cylinder is pi r squared h, but I know here, this is what I want to show that V is equal to, and there's no r in my solution that I'm looking for. So therefore, that's why I isolate r in this case, and I sub in 4r into the formula for the volume of the cylinder. Of course, it's going to be squared, so I'm going to be squaring 132, and underneath the line, I'm going to get 4 pi squared h squared. And when I simplify that down, the h squared underneath the line will cancel out with the h above the line, just the h, and you end up with 4,356 all over pi times h, and that would be meters cubed. Okay, and that was a 5-mark question. Now, we keep going here on to part 2. It says find h, corrected 2 decimal places. But I was thinking they had to give us a bit more information, and here it is. It says the capacity of the tank is 110 meters cubed. And of course, we know that capacity means volume. So in this case, since we know what the volume is, it is 110, and we have our formula for the volume. All we have to do is solve for h here, so we isolate h. We're going to get it corrected 2 decimal places, and the height, of course, is a unit of measure. In this case, it is meters, so 12.61 meters. So there was 10 marks for that part. So we're back to the kind of context and the story. In order to check an error in a gauge at the top of the cylinder, so like you might be thinking of some sort of gauge up here, a specialist ladder is used. In order for the ladder to be safe, there must be an angle of 75 degrees between the ladder and the ground. Between the ladder and the ground. Find the length of the ladder correct 2 decimal places. So here's my angle of 75 between the ladder and the ground. I know the height of the cylinder. So the length of the ladder will be the hypotenuse of this triangle. And because it's going to be a right angle triangle, because it's a horizontal base and vertical height, I can use my trig ratios. The 12.61 obviously is the opposite. X is the hypotenuse, so I use sine of 75 is 12.61 over x. X is 12.61 over sine of 75. I'm having a look back at my question. It says correct 2 decimal places, so I end up with an answer of 13.05 meters. Okay, 13.05 meters. And, we'll be confident that that looks right based on our previous answers. So that was a 5-mark question. Now, we're into another part. It's now talking about apple juice rather than orange juice. So the type of juice doesn't matter naturally to the question. But what matters is we're into another part of the question. It says when apple juice is produced, I thought there was something wrong with what I said there, but no, there's juice is mentioned twice, apple juice and produce. The cylindrical tanks are positioned in groups of 3. Each tank has a radius of 3 meters. They stand upon specialist matting as shown. The 3 tanks are touching. The radius of 3 meters, I suppose, is going to be important here. In order to position the tanks correctly, they're placed exactly on the matting using a precise plan with centers of each cylinder being placed on the vertex of the triangle as shown. Okay, so the center of each of the circular bases of the cylindrical tanks are at those points as shown. Show that the length of the line segment from point A to point B is 3√3. So what you'd be saying in this case is, now you'd want to read through that a few times, highlight the key bits. You will have time in the paper because of the nature of the fact that you're doing 4 short questions and 2 long questions, so there will be time. So do take your time with this. This is what we're looking for, AB. We have these 2 lengths here to be 3. Okay, so knowing that, and I think we're going to have one more bit of information here, that this angle here is going to be equal to 120 degrees. So the angle here is going to be 120 degrees. I'm thinking to myself, how do we know that's going to be 120? Well, we know it because this guy is 90. He's inside in a square. This guy is 90. And this triangle here is an equilateral triangle. So all the angles will be 60. So in this circle, we have a 90, a 90, a 60, and an angle remaining. So this angle remaining then is the 120. And our angle remaining is the angle ACB. So it's 120 degrees. So knowing that, I can then use my cosine rule to find the side length AB. So I fill in everything I know. I simplify down, I get AB is equal to the square root of 27. And the square root of 27, of course, is 3√3 as required. So one thing I would have mentioned actually earlier, if I thought of it, was that it is a good idea to fill in as much information as you possibly can on this diagram before you start. So you do know a lot of the lengths and the distances, etc., and the angles. So we're saying the radius of all of these are 3. So all these distances here are 3. Inside in the triangle, we'll know that it's an equilateral triangle and that all angles there would be 60 degrees. And so there's a lot of information you can fill in. Then when you're dealing with any particular triangle or shape, it's a good idea to draw them out separately. Okay, because it'd be easy to go wrong. That was a 10-mark question. Find the exact area of the triangle ABC. Well, once we have, once we know that that angle is 120, this is actually pretty easy because it's a half, one side times another side times the sine of the included angle, half 3 times 3 times the sine of 120. It's 9√3 over 4 meters squared. And that is the exact answer, so not rounded. So we keep it in third form. Hence or otherwise, find the area of the matting not covered by a tank. So again, you might have to go back and read back to the question. So it's not covered by a tank is what we're looking for. The tanks are the 3 circles. They're the circular bases. Give your answer correct to 1 decimal place. Okay. So, again, in the actual exam, if I was doing it, I'd be writing and drawing out these shapes separately. We know that this side here, this triangle ABD, well, to find the area of that, it's a half 3√3 times 3√3 times the sine of 60. Why is that? It's because it's an equilateral triangle. The angles are 60, the sides are the same, and we know that the side AB is 3√3. So therefore, I can say any other side, like, so if I'm saying this is 60, I can say this is the 3√3 and this is 3√3. So it's a half 3√3 times 3√3 times sine of 60. That's equal to 27√3 over 4. There are 3 triangles of the same nature there. So I'm going to be multiplying that by 3 to get 81 root 3 over 4. So if I just highlight that guy in orange for a second. So that's one part of my solution. I was getting there anyway. I know this triangle in the middle is a half. 6 times 6 times the sine of 60. And why is it 6? Well, we know the radius of the triangle is 3, so there's 2 lots of 3 there. So therefore, that'll be the 6. And again, it's an equilateral triangle. So we're dealing with this triangle. That'll be 9 root 3. I'll just highlight that in yellow. The area of the triangle ABC, we calculated that a moment ago. That was 9 root 3 over 4. And there are 3 triangles of the same nature there. So those, when I multiply through that, I'm going to get 27 root 3 over 4. And last but not least, we have these squares. And the squares are distance 3 times 3 equals 9. There are 6 of those squares, aren't there? So we have 54. And that's 54, and I think it'd be meters squared. But I'm going to add all these areas together. I'm going to get a total area of 116.3538. That's for the entire overall shape, the overall triangle. The matted area is the total area minus the area of the circle. So we have our total area. The area of the circle, well, the circle is radius 3. So the area of the circles is pi times 3 squared, and there are 3 of them. So that'll be 84.823. 84.823, that's the area in red. I'm going to subtract that area in red away from the total, and I get left with the difference. When I look back to my question, it said correct a 1 decimal place, and of course I need to have my unit in there of meters squared. And that was 15 marks. So that's the end of that question. I would say, you know, a bit of work in it to get there. A lot of people, you know, if you're good at trigonometry and geometry, if you can see, I suppose, the symmetries in the question, see that certain sides must be equal to each other. Because, for instance, the fact that these are equilateral triangles we're dealing with. If you know that, then maybe the question becomes fairly straightforward for you. But if you didn't spot that, it becomes a very difficult question. And in that situation, maybe the next question, question 10, the probability question, might be more in your line.